Okay, now we're going to look at cardinality. Cardinality is when we're just concerned with the number of elements in a particular set. This helps us for probability that we're going to do next, when we can figure out percentages and probabilities and make inferences. Also for statistics, that'll be a great help. We're going to combine that with the union and the intersection properties. So we're going to use a Venn diagram to figure out this problem. I'll also show you how to use the formula. So we are going to use this notation here, the N of A, number in set A is what that stands for. We have a survey of 200 people. They're asked, what beverage do you drink in the morning? And offers choices tea only, coffee only, or both coffee and tea. Suppose 20 report tea only, 80 report coffee only, and 40 report both tea and coffee. How many people drink tea in the morning? And how many people drink neither tea nor coffee? So these are our questions of interest here. I'm going to draw a Venn diagram. You can see if you can figure out, pause the video and do that on your own. Okay, as you can see here, I have filled in the Venn diagram. Up here is our U for the universal set. We have 200 total. So we want to fill that in the corner somewhere or outside the box, just knowing that that's limited to the 200 people that were asked. Then we have the T only, which is 20. So T all together is this entire circle here. So all together we have 60 that have T. If we look at the coffee only, then we're going to have just the 80, but remember the overlap is 40 where they intersect. So we have 120 total for the coffee. So if we wanted to use these numbers in the Venn diagram and we're trying to think of how many people drink tea in the morning, the total tea drinkers, we can either figure that out from the formulas that we used before, but it's really just nice on this chart here. We have 20 and 40 put together, the people who are only tea plus those who drink both, we would have 60. So now figuring out how many people drink neither tea nor coffee, we have to use this number 200 there and then subtract everything that's in the circles. So we can take our U, the number in the universal set, and we're going to subtract we're going to subtract the number of our union, T union C, tea and coffee, or coffee, I should say, and that all together is our 20 plus our 40 is the 60 plus our 80 is 140. So all together we have 60. Drink neither. So before we go on to our last page of this, I want to point out these formulas here that we're using. Property 1, the number in A union B will be the number of A plus the number of B, but don't forget to take off that intersection. You want it in there once, but you don't want to double dip because it's in A and it's in B as well, so we have to subtract that off. Here's if you're trying to find the complement, property 2. And sometimes we need to rearrange things a little bit. So to find the intersection, we can add up the totals and subtract the union. Now we're looking at page 36 in your workbook. Example 3.13, suppose set A contains 48 elements and set B contains 56 elements. If sets A and B have 25 elements in common, what is the total number of elements in either set A or set B? So if we think about what the formula for the union is, that would be the number of A or B equals the number of A minus number of plus number of B minus their intersection. Now that one's not too sticky to figure out, so I am going to leave that one as a classwork for you to do, and then I'll go back and fill in. Okay, so I've started with the formula. This is property 3. Finding the intersection here would be equal to the number in A plus the number in B minus the union. So this question is a little tricky because it says, so we have the 69 teachers. That's pretty easy to plop in there. The Bothell school is 97. So that's straightforward. But now it says the total number of teachers at Albers and Bothell combined is 141. Well, what they really mean is and or, and that's the union. It's both schools. There's 141 altogether, but we just want to find out who works at both. So if we have this being our intersection here, that's really the A and B. So the number in A intersect B, just do these calculations here, and we get the 166 minus 141, we get 25 work at both. So I think sometimes the vocab in the language is a little confusing in the question, so I just want to point that out. This next problem down here, 3.15, see if you can figure that one out on your own by doing it as a classwork. And I'll put the answers up momentarily, so you can just pause the video, do them right now, and I'll put the answer on. Here's the answer to example 3.13 that I wanted you to do for classwork. 79 elements is the union. That was our example that we did. And this classwork here, example 3.15, 14 own neither. So this one you just have to figure out the union first inside here by the information given, and then don't forget to subtract that off of the universal set there. Okay, so that is our end of the set videos. So go ahead and finish up any classwork problems that weren't completed here, and then submit, and you can check your solutions. Have a great